Bar charts and pie charts help us visualize data, but specifically categorical data. What we're going to look at next, histograms, are one of a variety of graphs that help us visualize quantitative data. At a glance, the two graphs below look a lot like a bar chart, but there are a couple of distinctions to pick up on. One is that with bar charts, the bars are usually drawn with some separation between them, whereas with a histogram, the bars line up just right next to each other. The other thing to notice is that along the x-axis, the horizontal axis, rather than having categories or names, we have numerical values, because what we're doing is collecting numerical data in this case, or quantitative data. Our y-axis, our vertical axis, still represents the frequencies with which different responses occur. But now, since we're not dealing with categories or names, what we have are ranges of values along that horizontal axis, that x-axis. So really, this is a visual representation of the binned frequency distribution that we created last time. In this case, we have a bin width of 2, since that first interval ranges from 0 to 2, and that same bin width applies for each of these bars. And then what we can look at is the frequency, which in this case would be, for the first one, 4, telling us that there were 4 countries where the number of kilograms of coffee consumed per person per year was between 0 and 2. The next frequency is 6, so there were 6 countries where people consumed between 2 and 4 kilograms of coffee per year. And on we can keep counting up those frequencies until we get the last one, where we see that there were 2 countries where people consumed between 10 and 12 kilograms of coffee per year. Individual people. An interesting thing about histograms is that the graph on the left and the graph on the right are actually visualizations of exactly the same data. At first, that might not make a lot of sense, since these graphs look quite a bit different from each other. But what happened is, to get from the first graph to the second graph, we adjusted the bin width. So now, this bin width spans a width of 3 units, and that same bin width is applied to each bin. So we're collecting the data differently. Previously, if a country had between 0 and 2, if individuals in a country consumed between 0 and 2 kilograms of coffee a year, they went in that first bin. In our second graph, now it's anyone where individuals consume between 0 and 3 kilograms of coffee per year. And that changes our frequency, so we get a frequency of 7, 6, 3, and 3. So histograms can change shape, the picture can adjust depending on the bin width that we use. So we need to think about the bin width that we use. Either there's something natural that might suggest that, or there's a decision that we have to make when we create a histogram to know how to separate or break up that data. But the key thing is that changing that bin width can change the look and picture that we see when we visualize that data. In example 5 now, what we want to do is use Desmos to create a histogram. Below we have data that's provided on the gross gaming revenue, so gambling revenue, of casinos in the United States in 2022 by state. Something to mention here quickly before we move on is that this is in millions of dollars. So this first example, our first result for Nevada is 14,842. So 14,000 or almost 15,000 really means about 15 billion. Versus if we get all the way down to the bottom of the list, this is a little over $7 million. So just to have that context for those values in place. This information is presented as a table, also as a list, because that's easier to copy and paste into Desmos, or you can use this link to jump straight to this data already entered in Desmos. So that's just a lowercase l, which we can use almost any letter we want to name our data set. We put all those values in a set of square brackets separated by commas, and then we type in histogram. I'm having a lot of trouble typing that for some reason. All right, there we go. Histogram, and then we type in the name that we gave to our data set, which in this case was L. Then we put a comma and our bin width. In this problem, we're told to use a bin width of 1000. And then what we want to do is change the bin alignment to be left. Sometimes center is used, but for our purposes, we'll just stick with left. If you notice, what it does is centers the bar over 0 or makes 0 the left endpoint of that. We can actually see that a little bit better if we click on this magnifying glass first and zoom fit to our data. So as we change that from center to left, it just changes how those bars are aligned. But we've created our histogram with a bin width of 1000, which is, again, equivalent to $1 billion since it's 1,000 million. And we can see the frequency of states that make between 0 and $1 billion from gaming revenue. And then we've got one value way out here on the far right end, which we can probably guess is Nevada, with Las Vegas and all the other different gambling options out there. And like we mentioned, we can also adjust the picture of that data by changing our bin width. So instead of 1,000, if we said, say, 500 or even 5,000, we start to see different pictures that all represent the same data, but as we adjust that bin width, it changes the picture. So either a problem will give you a bin width to use, or we need to, if we were creating this data in a real-world setting, in a real-world application, we would need to make some logical choice for how those bins should be separated or sorted out.